Okay, today we're going to be looking at how to measure a circle. Now, we've already talked about several ways to measure a circle. One way we can measure a circle is in degrees. Degrees is the total distance around the circle. So if I went all the way around that circle, that would be 360 degrees. There are 360 degrees in a circle. Another way we have measured a circle is by the circumference. The circumference is the distance around the circle. And your formula for circumference you should have learned already is circumference equals 2 pi r, where r stands for the radius. Now, a third way, the difference between these is degrees is kind of talking about how far you turn. Circumference is the distance you go. There's kind of a cross that still uses that radius to relate to how far you turn, and it's called a radian. A radian is basically a unit of measure that makes an arc equal to one radius. So it makes an arc that is equal to the radius, and that's how much of a turn a radian is. It's based, instead of degrees, 360 all the way around, it's a certain number of radiuses around. So what we have here is, I'm going to mark all over this circle. We can see the radius of this circle has been marked as 3. There it is, the radius. And you can see I have marked off radians around this circle. Basically, if you took a piece of string and cut it off to be this distance of 3, if I line that string up along the outside edge, you can see that red segment there, that arc there, would be 3 as well. So that is 1 radius around the circle. Then you see in green, I have another one. That's another distance of 3. So that's 2 radiuses for a total of 6. 3 radiuses for a total of 9. 4 is 12. 5 is 15. 6 is 18. And then I have a little bit more there, and we're going to talk about that a little bit more. Now, basically, if I was using my circumference formula, I would have 2 pi times 3. Well, you notice that if I did 2 pi times 3, if I plug that in, I'm going to be able to get a decimal answer that's going to be 6 pi. And pi is about equal to 3, so this is going to be a little bit more than 18. Actually, it comes out to be about 18.8. Now, the reason I mention this is you notice that you've been doing circumference for a long time, and basically circumference, you're saying it's about whatever the radius is, I'm multiplying it by a number that's close to 2 pi. In other words, I'm multiplying it by a number that is pretty close to 6, because 2 pi is a little bit more than 6. So you can see that 3 times 6 would have been 18. Since pi is a little bit more than 3, it's 18.8. How this relates to the radius and the radians is, if you count, I have 1, 2, 3, 4, 5, 6, and a little bit extra. In other words, I have a little bit more than 6, or it turns out to exactly 2 pi radians are in a circle. Because I could take about 6 of those radius string lengths and put them around the circle, or exactly 6.2, or even more approximately, I guess, 6.28 of those radius lengths are exactly 2 pi of those radius lengths to make it all the way around the circle. So there are 2 pi radians in a circle, and that means 2 pi radians is equal to 360 degrees, because those are equal to each other. Now, we're going to show you a little bit of what we can do with radians here in just a second. Okay, one thing I need to be able to do with degrees and radians is to be able to figure out the angle in a coordinate plane. So, for example, if I had an angle of, let's say, about 60 degrees, this looks like it's about a 60-degree angle. That would be 60 degrees would be that far around. Now, if I went a little bit further around, if I went all the way over here, this might be an angle more like 150 degrees. So the further you go from the positive x-axis, you start at the positive x-axis and turn around, and you can keep going. So actually, we'll do this one in purple, but if I went all the way over here, this might be something close to maybe 300 degrees, because I went so far around. Straight across is 180, Straight down is another 90, so 180 plus 90 is 270, so a little past that might be 300 degrees. The further you go, it's all the larger the angles get, until you make it all the way around would be 360 degrees. And this brings up a point of what a coterminal angle is. Coterminal means it stops in the same place. So a coterminal angle is an angle that stops in the same place. So the angle of 0 degrees and 360 are coterminal because they stop in the same place. Now the truth is, if I'm in degrees, every time I spin around 360 degrees, I get a coterminal angle. For example, we'll mark this one in red. If I started in the middle here, like I was going to that 60 degree angle, but instead of doing that, I went all the way around and then back to 60. What I would have for that angle is 360 to get all the way around, plus another 60 would be an angle of 420 degrees. So that means 420 and 60 degrees are coterminal because they stop in the same place. So co meaning together with, terminal means to stop. You can think of like a bus terminal, or even the movie The Terminator. That guy made a lot of things stop working. So that is coterminal angles. As we're looking at coterminal angles, another thing to point out is we'll go ahead and mark our 60 degree angle again. If this is 60 degrees, it is possible to go in the opposite direction. So if I went this way, instead of turning 60 degrees in a positive direction, I'd be turning about 300 degrees in a negative direction. So a positive turn is a turn going toward the positive y-axis. A negative turn is a turn where you start going toward the negative y-axis in a clockwise direction. So it's negative 300 and 60 are also coterminal. So you can notice I could take the 600 like I did a minute ago, and I could add 360 to get a positive coterminal angle of 420, or I could subtract 360 from 60, and that would give me a negative coterminal angle of 300 degrees. But the truth is 60, 420, and negative 300 are all coterminal. And if you wanted to, I could take negative 300, and I'll do this one in red. I could do all the way around and then go that negative 300 degrees. So basically, I would take the negative 300 and subtract 360, would be another coterminal angle of negative 660. Or on the other extreme, I could take the 420 and add another 360, and that would be a coterminal angle of 780. You can basically just spin around a little bit more. Maybe it's just for style. You're trying to think you're a snowboarder or something, and you just like spinning around in circles. But 780 basically means I spin around once, I spin around again. That's 720. 60 more makes 780. So every time you can keep spinning extra spins, and it's coterminal angles. Now the important thing to coterminal angles is if I notice an angle is coterminal, it's common to just try to find the simplest form, the value between 0 and 360 to do for these coterminal angles. Now that we looked at coterminal angles, let's look at them also in radians. So as I look at coterminal angles in radians, we're going to start with this. And let's say that this was equal to let's say that this is 1 radian. So if this is, actually, let's be a little bit prettier than that. Let's say that this is equal to pi over 3 radians. And you might say, that's not pretty. Well, since radians are in terms of pi, it is going to be easier usually to use radians if they have a pi in it. So if that is pi over 3 radians, roughly, let's just say it's a sketch of pi over 3 radians. What I need to do is figure out what would be coterminal with that. Well, if all the way around the circle is 360 degrees, it's also equal to 2 pi radians. So what I'm basically going to do is I'm going to take this pi over 3, and I'm going to add 2 pi radians to it. Now, if you want to, you could do this in a calculator and basically just do a 1/3 plus 2 and just stick a pi on your answer, because it's basically like you're not worrying about the pi until the end. 1/3 plus 2 would be 7/3. So it's 7 pi over 3, or 7/3 pi radians would be coterminal, because 2 pi would be all the way around, and then a little bit more would be 7 pi over 3. To find a negative coterminal angle, instead of adding 2 pi, I would subtract 2 pi. Once again, if I'm dealing with radians, instead of adding and subtracting 360, which is all the way around the circle in degrees, I'm just adding or subtracting 2 pi, some all the way around the circle in radians. So in this case, once again, you could just think of that as 1/3 minus 2 in your calculator. No need to type the pi in your calculator. If you want the answer in terms of pi, you want pi on the paper. You don't need it in the calculator. So that's going to be a negative 5 over 3 pi, or negative 5 pi over 3, however you prefer to think of it. And once again, we'll mark this one in red, but you're basically talking about, instead of going in the positive direction, you're going to go in a negative direction, negative 5 pi over 3. And you do notice if you add those together, you do end up getting the full distance around the circle.